तो बच्चों, आज हम लोग जो एनसीईआरटी का आपका पहला चैप्टर है क्लास 12 का, दैट इज चार्ज एंड इलेक्ट्रिक फील्ड, उसके सारे क्वेश्चंस जो है इस वीडियो में हम लोग करने वाले हैं। तो पहला क्वेश्चन बेसिकली आपके स्क्रीन पे है। व्हाट इज द फोर्स बिटवीन टू स्मॉल चार्ज स्फीयर्स हैविंग चार्जेस ऑफ 2000 10 raised to minus 7 coulomb and 3 into 10 raised to minus 7 coulomb placed 30 centimeter apart. Correct. So let us see. We have two charges. Suppose Q1 and this is Q2, and the distance between them is 30 centimeter. We have been given Q1 is 2 into 10 raised to minus 7 coulomb and Q2 is 3 into 10 raised to minus 7. So these charges are basically both are positive charges. So what they will do? They will repel each other. Correct? So there will be a force, repulsion force between them like this. This is your F force on Q1 due to Q, and this is your force on Q2 due to what? Q1. You already know that F12 is nothing but minus 21, or magnitude of these two forces will be equal. Suppose this is F. So we know F is given by the Coulomb's law. What is Coulomb's law? That is 1 by 4 pi epsilon 0 into Q1 Q2 upon R square. Here R is basically 30 centimeter, means you have to put the things in the correct units. Correct. So let us put the value. What is the value of this? That you already know. 9 into 10 raised to 9 into 2 into 10 raised to minus 7 into 3 into 10 raised to minus 7 divided by 0.3 square. And this, if you can calculate, this will be 6 into 10 raised to minus 3 Newton. And what is the nature of this force? That is repulsive. So this was your first question. Let us go to the next question. This is the second question of the exercise. The electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge -8 microcoulomb in air is 0.2. So here basically you have been given Q1, Q2 minus, then force is also given. What is the distance between two spheres? So basically R is R. Now let us see, one small sphere is there. Another small sphere is there. Here charges is Q1, Q2. Here you can see opposite charges are there. So our force will be basically attractive. This is force on one Q due to Q, and this is force on 2 due to 1. Both will be basically same, and this will be basically F12 is nothing but F21 because their directions are opposite. Or you can say the magnitude of this will be equal, that will be equal, and that is given by 1 by 4 pi epsilon 0 Q1 Q2 upon R. Correct. Here we can put the values 9 into 10 raised to 9. Then Q1, Q2 are there, 0.4. They are given in microcoulombs. So -6 into 0.8 into 10 raised to -6 divided by R square. So this F is given. Basically, it is your 0.2 Newton. Correct? So here, if you see, R square is nothing but 9 into 10 raised to 9 into 0.4 into 0.8 into 10 raised to -12 divided by 0.2. If you calculate this will come as, R will come as 112 into 10 raised to -2. That is meter. Or we can say, so these spheres are placed 12 centimeter apart. Correct? Now, first part is okay. What is the second part says, what is the force on this second sphere due to first? Now, since the force is mutual, basically, I have already told you, this force is equal and opposite. Correct? So that means 0.2 Newton force will be on the second sphere by first. And of course, this will be attractive force. Correct? So, this was your second problem. Now, we should go to the third problem. Third problem says, check the ratio. So, the ratio is this, K E square upon G M E M P is dimensionless. Correct? Now, if we see Fe, that is electric force, what is this? K E square upon R square. And what is this? Gravitational force is nothing but G M E M P upon R square. These two formulae we know, and suppose if we take the ratio of this, then what will remain? K E square upon G M E M P. Since this is the ratio of the force, so this has to be dimensionless. I hope clear. Correct. Now, another part says look up a table of physical constant and determine the value of this ratio. What does the ratio signify? So let us calculate this ratio basically. Correct. So if you FA upon FG is nothing but K E square upon G M E M P. Correct. You know K value, 9 into 10 raised to 9 into 1.6 into 10 raised to minus 19 is the charge on electron and proton. Then you know G, value of G also 6.7 into 10 raised to minus 11. Correct. And if you put the value of this, it is around 1.6 into 10 raised to minus 27 mass of the proton into 9.1 into 10 raised to minus 31 kg. That is the mass of the electron. Please check up these values. And What you will get here? You will get the figure like 2.4 into 10 raised to. Now, this ratio is quite large. This ratio is quite large. That means electrostatic forces are much stronger than gravitational force. Correct? Then let us go to the next. Explain the meaning of statement electric charge of a body is quantized. So, meaning of electric charge quantized, the answer I have already written here. The statement means the electric charge exists in discrete packets, not in a continuous manner. The smallest unit of an electron is this. Basically, electric charge of a body is quantized, means Q must be in the multiple of the fundamental charge, that is the charge of an electron. That is the smallest charge exists, and whatever charge we see, that is in the multiple of this smallest charge only. That is basically the meaning of this quantization of charge. Any charge, so basically charge, fundamental charge, it's a discrete charge. It is not a continuous charge. Correct? Now, you cannot have the fraction of a charge. Then another part is there, why can one ignore quantization of electric charge dealing with macroscopic large scale charges? Large scale charges, if you see, we are dealing with in coulombs. Coulomb is a very and very big unit. Correct? And in 1 coulomb, if you see, these many number of electrons are there, are difficult to count basically these many electrons. Like you must have seen water. In the water molecules are there. And 1 mole of water contains 6.022 into 10 raised to 23 molecules. Can you see the molecules? No. You see the continuous water. Same case is here also. And large number of electrons are there in a charge. Suppose 1 coulomb charge is a very big charge. Even if you take microcoulomb, then you will find 6.25 into 10 raised to 12 electrons in 1 microcoulomb. This is a very big figure. That's why quantization, or you can say graininess of the charge is completely ignored. It is considered as a continuous, basically. It appears continuous, like your water appears continuous. If this, with this quantity, if the charge moves, then you cannot see the graininess of the charge. It will look like a continuous flow. Correct? So this is the meaning of this. Let us go to the next question. When the glass rod is rubbed with a silk cloth, charges appear on both of them. Of course, glass rod becomes glass rod becomes, here I have written, glass rod loses electrons. If it is losing electrons, then what will happen? It will be positively charged and still gains electrons, so it will be negatively charged. So there is a transfer of electrons from one and another. Correct? So here the question is, a similar phenomenon is observed with many other pairs of bodies. Yes, of course, ebonite rod, you rub that thing with the fur, like that. So many phenomena are there. Explain how this observation is consistent with the law of conservation of charge. Of course, because charge is not going anywhere. If you consider the glass rod and silk as an isolated system, correct? If you consider glass rod and silk as an isolated system, then what will happen? In the isolated system, since earlier glass rod was neutral, silk was neutral, if you see, there is a transfer of electron, there is a positive charge and negative charge. Both will be electrified, but total charge will be same. That means no new charge is created or destroyed. Charge lost by the ground, charge gained by the circle. Only transfer. That means total charge before means total charge after. So this is how the conservation, law of conservation is consistent with this phenomena. Correct? I hope you understood this. Now, let us see question number 6 of your NCERT book, exercise 1, that is chapter 1. Question number 6 is basically, let us draw the figure, then you can understand. There is a ABCD square is there. Correct? Suppose this is A, this is B, this is C, this is D. Now you have on A 2 micro coulomb charge is there. On B -5 micro coulomb charge is there. On C 2 micro coulomb charge is there, and on D -5 micro coulomb charge is there. Correct? What is the question? What is the force on a charge placed at the center of the square, 1 microcoulomb charge is placed at the center. So let us see. Here we have placed, suppose the center is O, there is one charge that is 1 microcoulomb. Correct. Now, let us find out the forces at the center due to this charge configuration. This A, the charge at A and charge at O, they are positive in nature. So, what will happen? It, it will repel this charge like this. Correct? Suppose here, if you see, since you see the center of the square, suppose this is A, this is A, this is A, and this is A. Correct? Now, due to B, minus 5 coulomb charge is there. So, it will attract this like this. Then, O and C, if you see O and C, they are positive in nature. So, another, this, they will repel. So, charge direction will be like this. And O and D, they are opposite in nature, so their direction of this force will be like this. Correct? So this is the force at O due to A. This is the force at O due to C charge. This is the force at O due to B, and this is the force at O due to D. Correct? If you see, let us find what is FOA. That will be K 2 microcoulomb into 1 microcoulomb divided by A square. Correct? Then what is the force OC at O due to C? This will be also same. But direction of OA is direction of OA and OC. These two forces is opposite. So this force will cancel with this force. Likewise, if you see FOB, K 1 microcoulomb into 5 microcoulomb upon A square, and FOD 1 microcoulomb into 5 microcoulomb A square. They are also both equal, but in the opposite direction. Correct? So this will also cancel. We are not writing minus 5 microcoulomb because we have already considered the direction considering as a minus charge. So what will be the force at center? Net force at center or at 1 microcoulomb, that would be correct. I hope this is it. Now let us go to the next question. This is a theoretical type of question. I have given you the answer. The electrostatic field lines is a continuous curve. This is that is a field line cannot have sudden breaks. Why not? Explain why two fields can never cross each other. So these are continuous lines are there because they are continuous. It depends direction of electric field. Why a sudden break is not there? Because electric field becomes zero abruptly because along the field lines the electric field varies, and if there is a sudden break of electric field, that means electric field there at that point that that will also change abruptly, which is not possible basically. Field lines cannot start or stop abruptly in free space. They start from the positive charge and the negative charge. Okay. Why do you never cause? Because they will have two tangents, they will have two directions of electric field at the same point, and that is not possible. That's why these two field lines cannot cross. Now let us see this question. Question number 8. 2 point charges QA and QB are located 20 centimeter in means QA and QB. Its value is 3 microcoulomb. Its value is minus 3 microcoulomb. Distance between them is basically 20 centimeter. And of course, since they are they are opposite in character, that means they are going to attract each other. Correct. What is the electric field at the midpoint O? So let us see it. This is the midpoint O. Correct. So EO. Suppose if we find out EO, huh? Electric field due to what is this? This is your electric field at O due to charge QA. Correct. And what is the electric field QB at O? Of course, this is a negative charge. Then electric field will be towards the charge. So here again, there will be EOB, electric field at O due to B. What is the value of this? Now EO will be nothing but EOA plus EOB because both are in the same direction. Correct. So this will be KQ upon R square, or you can say this is the midpoint, this is the distance. RA, you can say this is resistance RV. So RA square plus KQB RB square. We can take 9 into 10 raised to 9 Here RA and RB, since this is a midpoint and that is equal to 0.1 meter, because it is 20 centimeter, the 0.1 meter. So 0.1 meter square QA plus QB 3 mu plus 3 mu, and this will be basically, if you calculate it, then this will come as 54 into 10 raised to 5 Newton per coulomb. Direction will be along OB, correct? That is the electric field at O. Now, what is the, if a negative test charge of magnitude this is placed at the turn, what is the force experienced by the test charge? Of course, force experienced by your test charge, FO you can say, that will be Q0 into E0, and here negative test charge is there. So minus 1.5 into 10 raised to 9 into 54 into 10 raised to 5. Correct? So if you calculate is, it will come around 8 into 10 raised to minus 3 Newton. But now here this is minus. Electric field direction was along OB, but since it is a minus charge, now the force will be on this, the force will be along OA, correct? Suppose if you put positive charge, naturally the force should have been along OB in the direction of the electric field. But since it's a negative charge, so it is along the OA, means opposite to OB, correct? So this was the solution of this thing. Now, let us stop here. The remaining questions we are going to do in the next video, in the next live class. So you can go through once more all these questions, and you can send your comments. How was this video? We are going to bring all the solutions of the NCERT questions on this platform very soon. If you have not subscribed my channel, then please do so that you should not miss anything, whatever is coming on this channel. Thank you very much. Bye.